Okay, we're back. So what I've done was I've changed the screen grid resistor, and for the screen grid, and you can see I changed it to a 220K, which gets me under that 225 volt maximum that you're allowed for screen voltage on these tubes. Right now there's 189 volts on there. And if you look up here, I'm floating right around 425 volts right at the plate. If you look across the 470 ohm resistor, there's about 17 volts. Okay, so let's write these numbers down. Okay, so V cathode is 16.9 volts. Screen voltage 189, and plate voltage is about 425. And now I'm only putting about 105 volts or so into the amplifier, so I am going to have to cut the voltage down a little more by putting a bigger dropping resistor in there. Alright, so let's shut this down right now. Okay, and let's do a little bit of math. Okay. Welcome back, by the way. We're in part 3 of our series on the guitar amp. So what we basically did was we changed this 24K up to a 220K. All right, now I'll change all these notes when we get everything how we actually want it. And this is a 470, it always was. Okay, I started out with that. So right now, we're getting about 189 volts here, but more importantly, up here, we're getting, if I apply 425 volts up here, I'm getting 16.9 volts right here across that 470. Now let's do a little bit of math. Okay, Ohm's law, we just want to find out the current flowing through here, because in a series circuit, no matter where you measure the current in a series circuit, the current is always going to be the same. So the current through here, the current through here, the current through here, it's all going to be the same current. So when we know what this is, we can also know what the current in the tube is. So if we take 16.9 volts and we divide that by, okay, our 470 ohms, that is going to equal 35.9 milliamps, or 0.0359 amps. Now, we measured our plate voltage, the voltage sitting at the top of our plate, and it was 425 volts. So if we take the current times 425 volts, you can see we're getting about 15.2 watts of dissipation. Now that little transformer, the output transformer that we're using, it's rated between 10 and about a 15 watt transformer. So we don't want to run that transformer any hotter than that. So what that's saying is, if we can get this to sit at 425 volts, the way everything's set up right now, that's going to be almost perfect for where we want to be with all this. Okay, so that's it. Now, how did I arrive at all this? Well, there's a few things. Number one, you have to look at the tube chart, okay, the product information for the particular tube you're working on. So this is for 6550, you know. So basically, this is roughly what you're going to see for most 6550/KT88 tubes. And if we go to the Class A section, okay, the maximum you really want to dissipate through the tube in Class A is about 20 watts and about 400 volts there, and about 225 volts there. Now, our maximum ratings here is way up high, 660 volts and 500. So, you know, this is just showing how this thing's going to perform at this. If you go another 25 volts, okay, some of these numbers are going to change a little bit. Obviously, your current's going to have to drop, okay? But you can see at 400 volts, your zero signal DC plate current can be is going to be around 87 milliamps, and I'm running a lot lower than that. So this thing is going to run really cool, because we're only going to, even with the higher voltage, we're going to go at even lower milliamps than this. And we're only going to float this, instead of running it at 20 watts, which is recommended, we're only going to run it at about 15. So it's going to be a nice, cool running amp. The tubes are going to last a really long time. Okay, and that's how I arrived at all this. Now, back to what I said originally. I rough sketched out a schematic and came up with some rough ideas from looking at some other existing amps and so forth. That's a good way to start. And then I kind of started massaging these numbers into where they need to be. So for right now, we've changed this one. We've changed this one. Okay, so we've made two changes here. This is 200 ohms right now instead of 150. We're probably going to end up bringing that up even more. Okay, because what's happening is I'm getting closer to 500 volts if I crank my incoming voltage to the full, 125 volts, into it. I'm only running about 102, 103 to get that 425. So we need to drop this down so that this B plus is floating right around 425 volts. And remember, the reason we're going through all this is because we're using parts that we have on hand. Okay, we're not custom designing this and buying all our parts. We're making do with what we have. And even though we're going to make compromises to get everything to work, when we're done, this will be a properly designed amplifier, and it's going to work really good and sound really good. So right now that's where we are. And now the next move we're going to make is we're going to get this adjusted so that we can get 425 volts here with 120 volts going in. All right, that's our next goal. Then the next thing I'm going to probably do is I'm going to set this circuit, and basically now that we know that this is going to be sitting somewhere around 20 volts, all right, or something close to that, I'm going to adjust these two values so that at this center tap I'm going to get somewhere around under 20 volts, but more than 0 volts. And by the reason you do that, okay, that's called raising your filaments, okay, elevated filaments. And the reason I'm doing that is by elevating the filaments, that's going to move the noise a little bit further away. If you get too big of a difference between the voltage potential related to ground on the filaments and the voltage potential related to ground on the cathode, what ends up happening is you start generating noise in between these two. The other thing is you can have electrons actually start moving between these, and we don't ever want electrons to flow between the cathode and the heater. The heater should only produce heat, and the cathode should be the only thing that emits the electrons with respect to the rest of the circuit. So 20 volts, I don't know, we'll have to see. That's going to be pushing it, okay? And we may start getting a little bit of extra hum or extra noise, so we're going to play with this. I'll set this to maybe about 15 volts, which is lower than the 20, but you only got about 5 volt difference. And that'll give us a little headroom here in case this drifts a little bit too, because you don't ever want this to go above the cathode voltage either. You want to keep it a safe distance below. Now if we were floating this cathode really high, we had 100 volts on here. There's a limit to what you can have, and it's somewhere here they tell you where it says filament to grid. Here, heater cathode voltage, heater positive with respect to cathode. They really don't want that to change more than 100 volts. So really you could float, there could be 100 volts sitting on the cathode is what they're saying, and this would still not emit any electrons. But it's still, the higher this goes, the higher the probability you have for a noisy circuit there. So, getting a 60 cycle hum. So we're going to play with that a little bit. If we don't like it, we can always bring it back down to 0 by grounding this and taking this out. So I hope that gives you a little idea. The math is pretty simple. I mean, really, all we did, like I said, was we calculated the current through the cathode resistor by measuring the voltage and knowing the resistance, and then we applied that to how many volts is up here. Okay, and you've got you got your 425, and technically you would take 425 and subtract your 20 volts, so that'd be 405 volts, and then put your current in there, and that's how much the tube itself is dissipating. But if we use the overall plate voltage, what's sitting at the plate, that's giving you the dissipation of the entire circuit. Okay, so that gives us an idea, and the idea is, now this is for 6550. If you were using a smaller tube, these numbers would have to be would be different from this, because you would have a lower maximum wattage and so forth. The other thing, this is a Class A amplifier. Since it's running at Class A, you can run it close to its maximum wattage sitting at idle current. Now if it's Class AB, which is a push-pull amp, you would actually run it at about 70% roughly, because when you're in Class AB, when you start putting a signal on here, what's going to happen is this current in here raises and lowers a little bit, up to 30%. So that's the 70% idle current. Whereas with Class A, this never changes. Even when you apply signal to this, this will remain the same. So hope that helps you understand a little bit about design and how we do it. And again, this is still theory. Nothing is ever exactly as you calculate it. So we still may get this all put together, and I may apply a signal to this, and it may not do what I want it to do. So we'll go back to the drawing board and we'll adjust these numbers again until we get it just how we want it. All right, so it's getting late here, and I'm going to turn it in for the day. But thanks for coming with me on this one. More to come here shortly. Okay, I'm not sure if I got that last one because I looked and the camera wasn't recording. So we're going to go and do this all over again. What we've done is I've connected a 1.5K resistor in here in place of the 200 ohm in our Pi network. That's dropped my voltage down to about 440 volts, okay, at the plate. That's also given me about 17 volts of cathode bias and equals about 36 mA of tube current. And when we times that by the voltage, which is 426, you take the 443 minus 17 volts, there's 426 volts across the tube at 36 mA. That's about 15.5 watts roughly, okay, right around 15 watts, which is a happy place for the output transformer. So with that being said, I took my little audio generator and I connected it through a little decoupling capacitor into pin 5, which is the input grid of the output tube, and connected my dummy load to my scope to just see what we're going to get. So if we crank this up, all right, we got to wait for everything to stabilize. Okay, wait for everything to warm up. And you can see, here it comes, and it'll come up to about 17 and a half. It'll float around as it warms up. This will stabilize. Okay. And up here you can see between 435 and 440 volts. Let's see if we got that. You can kind of see that on the video. And if we go up to our scope, we zoom right in on that, and we turn up, and you can see I get a really nice sine wave. Very nice and clean, no hum, no noise. Looks good. Okay, so again, what I've done is I've replaced the 200 ohm dropping resistor in the Pi network with a 1500 ohm. And like I said, I wasn't going to purchase any parts, but I did kind of break my little promise. I said at the first video that we may have to buy a couple small components. I didn't have a 1500 ohm chassis mount, and I would really prefer that over this, and they're only like $2 or so. So I ordered one. And we're going to replace that 200 ohm with the 1.5K. That's going to drop us right where we want to be. And the next thing we're going to get into is going to be the preamp. Once we get this all put together and we're happy with it, that's all good. So the next thing we'll talk about then is all of the challenges in designing the preamp. Now, a preamp in a guitar amplifier is extremely important, and for different reasons than it is in a an audio amplifier, because the preamp actually controls when the amp breaks up, or when it clips, or when it distorts, and that distortion is actually desirable with a guitar. And you can have symmetrical distortion or non-symmetrical distortion. You can distort at the you can overdrive at the beginning of the preamp, you can overdrive at the output stage, and even cause overdrive with the type of speaker and speaker magnet that you're choosing. So we'll get all into that later. But for right now, I think everything's looking pretty good. Alright, next update here. Let's see how bad I can mess up the lighting here. Okay. Anyhow, I hope y'all can see this. So where we are right now is I've made the changes on the schematic. Ended up having to put a 270K resistor here, and I'm still not 100% sure that's going to be perfect, but calculating through the currents and everything that should be in here, this should be 270K to get my 180 volts or so that I need here. We'll come to that later because I haven't built this yet. I made a little mistake on my schematic. I noticed that this input resistor needed connected up here, not to the wiper of the tone control, so I changed that. Change this to 470. Okay. Change this to 220K and a 470K. And I did not put this elevated filament yet. I tied it to ground. Okay, and we're going to see how that works. Again, you can have up to 100 volts here, potential difference between the filament and cathode, and we don't have anywhere near that, so I think we're safe. So those are all the changes I made, and right now I'm getting, I'm saying approximately 460, but it's really closer to about 450, 450 volts B plus, and this voltage divider here is giving me somewhere around my 190 to 200 volts on this, although the maximum on this can be a lot higher, so I can raise this if I need to get a little more gain out of the system. But I'm going to try it right here and see how it works. Alright, so everything's working right now. Looks good. The amp's quiet. When I inject the signal into here, I'm getting an output. The maximum of my little audio generator that I can make this thing go is only about 5 or 6 watts output. I'm not getting the full power, and I'm not getting it to clipping. So, and that's because I don't have enough voltage swing in here, in this area right in here, to to drive this tube all the way. So with that said, here's what it looks like. Alright, I'll change the view a little bit. And as you can see, I'll tip down, I have my two pots, my volume and my tone, and there's my little tone circuit. Here's our coupling capacitor to our driver tube, and I really haven't wired any of the driver section at all yet. I'm still going to do that. But all the rest of this is done and finalized and working. So I guess our next thing now is I'm going to start wiring this up, which is really going to be a pretty short task, because when you look at it, there's really not a whole lot of components to go in here. So I'll have this all wired up, and when I go to do my test of this, I will come back. Okay, we are back, and it is time for the good, the bad, and the ugly. I got this, I want to hit the tubes here. Basically, as you can see, I did the little bit of a wiring job on the driver tube and the preamp, and I got that set up, and I finally got to put power to this thing and try it out. Now here the good was, it did kind of work. The preamp did work, it's quiet, and I was getting somewhere in the line of about 40 volts or so peak to peak drive at this point here, right where it's going into the pin 5 grid, control grid of the output tube. That's a good thing. However, whenever this tube starts to ramp up and you get more than about 2 or 3 watts into it, what I think is happening is the transformer, after doing a lot of checking here, it looks like the transformer is probably saturating because of a impedance mismatch. Now, we knew that could possibly happen. If you go online and you do a lot of reading about KT88/6550 tubes and using them in a single-ended configuration, you'll find out that opinions are all over the place as to what the proper plate impedance should be for your output transformer for that use. I've seen anywhere from about 1.5 or 1.7, 1.5K ohms impedance, clear up to 5 or 6K ohms or 7K ohms. We have quite a bit of latitude with our current transformer, as we saw here, with all the different, here's 4 different impedances I can get, all with an 8 ohm speaker. And I've tried the different combinations, and the bottom line is, it just will not, I cannot get any output from this. Now, I've tried that. I've tried changing the biasing. I've tried biasing the tube hot, 90% like you're supposed to. I tried biasing it light, 50%. It doesn't seem to care, and no matter, it doesn't seem to be the tube itself that's flattening out. It seems to be a mismatch of impedance, which doesn't surprise me. This is a transformer, like I said. I think what it came off of, and 30 years ago or so when I got it, and it's been laying around, who knows what it was originally for, but I kind of think this transformer was, like a 2 6BQ5s, or something like that, which, those are 8K plate to plate. Very, very different specs than a KT88. Now, what are my choices? Well, we could try a 6L6 or a EL34, which I don't have either one of those on hand. I may have a 6L6. Have to check. The wife put some things away, and out in the storage unit, and I could dig around. But see if the impedance will be a little bit happier, with those tubes. Again, I don't want to purchase anything. The other issue we have is grossly high voltage for a single-ended amp. Most single-ended amps for this particular application, you're running 350 volts B plus or so. This one's 450 volts, and that's even after I really cut it down in the Pi network with this resistor here. Now, surprisingly, even with this 1.5K, I'm able to, this stays nice and cool, and I am able to maintain the idle current that you need for that output. But what I cannot do is, if I have 15 to 20 watts of idle current, of idle power in the tube, I can't get it to transfer properly to my output transformer, and that's an impedance mismatch. So again, this was a big experiment. Right now we're going to have to regroup and look through it and see what we can do to adjust for what we have. So what I want to do now is I'm going to probably upload this video, and then I'm probably going to try a couple different tubes and see how that works. I don't think I have any more transformers to try, on hand. I do have maybe, that's it. They're all in use, whatever I have. So, yeah, that's about where we're at. I could try winding one myself, but I don't have a winding machine, and I don't really care to get into that. But I'm not going to give up, but we may have to change. Now, there are tubes. I mean, there's so many different octal tubes out there that will have a more reasonable impedance match with this transformer. If we need to change tube types, definitely that's probably the easiest route. Now, we're going to have to play with our power supply and our biasing for sure, but that being said, that might be our best course of action. But I really, really wanted to see if I could get a KT88 single-ended. I've read a lot of forums that talk about it, and it seems to be a big challenge for anyone who has tried to make a guitar amp single-ended KT88 amplifier. KT88 is nothing like the other tubes out there, like the 6L6s. So, the amount of gain they have, the bias that they have to have, the type of drive they need on the input, they're supposedly more sensitive than like a 6L6 or an EL34. All those things add up to make them a little bit of a challenge for single-ended. But we're going to play some more. But I just wanted to give you an update on that. Maybe I'll fire this up real quick and kind of just show you what it's doing on the scope here and give you a little idea of what I'm talking about. And then I'll close out this particular video and I'll upload it. And then when we come back, hopefully I will have come up with some other options. So here we go. Let me get set up. Okay, so I've got everything turned on. As you can see, I have about, you can see about 19.5 volts of bias on my 470 ohm resistor. You can do the math for how many milliamps. I'm running about 457 volts right now on the B+. Okay, and you subtract your 20 volts from that, and that gives you roughly what the tube's absorbing for KT88, no problem. If you look at the bottom oscilloscope, okay, it's kind of a little hard to see, but let me zoom in a little bit. So right here, you can see I'm on the 20 volt per division scale, and as I drive this up all the way to clipping, right around there is where it starts to clip, and you can see I have about 80 volts peak to peak, or 40 volts either direction of swing. And right about the time that starts to break up, you can see that's about the same time that my tube starts to break up a little bit up here. So up here's you take a look there, you can see right about there. Okay, so right there is where we're starting to barely clip. Everything's tracking together, but if you look at my voltage there, I don't know if you can see that. I don't know if we can, this is hard to see because of the light. It's about 3.4 volts. Okay, so you have 10 volts, 12 volts, something like that, divided by 8. Okay, so you're only getting a little over a watt and a half, couple watts, and that's all this thing will do before it starts to break up. Now, I would expect to see an awful lot more drive out of that tube with that much drive going in. Not sure. The other thing we can try is try to increase that drive voltage even more into that tube and just see, let me shut this down, and let's just, and kind of just see if it's not the transformer. Maybe I'm not getting enough drive out of my preamp. The only clue that I saw that was a little bit curious is that at the very same time that the preamp would start to distort a little bit, the output would start to distort at exactly the same time, even though the distortion was more pronounced. That gives me a little hint that maybe it's not the transformer saturating. I don't know. So, you know, this is kind of where my vacuum tube expertise kind of starts to limit out. Something I've never been very good at, and I really need to get better at, I need to learn more about, is drawing a load line for an output tube and drawing a load line for a driver and a preamp. I think if I had a little better grasp on that and could do that a little better, it may help me understand this a little more. But as it is, I kind of have to do a little more trial and error. Information for a KT88 is scarce, even if you wanted to draw load lines, because really the only one that even mentions single-ended use is GEC, which is a very old, much heavier duty, well-built KT88 than the modern ones you get today. So, who knows? I don't know. You know, just limited information. Everything else I've downloaded has not been really helpful. So, that being said, it has somewhere to do in how we're driving this tube. And so it's either the drive voltage isn't high enough into the tube, or the transformer itself is reflecting back the wrong impedance. Although I will say, you know, my tubes are getting warm, but they don't get, you know, burn the skin off of you hot. So, you know, I don't think I'm red plating. I'm not getting any of that sort of thing. I'm not getting any blue glow in the tube. Nothing like that. I'm not really getting any kind of, as you saw, I wasn't getting any oscillation. It looked very clean. When I hook a speaker up to it, I don't really get any kind of, you know, I put this little speaker on here and no hum, real clear, but just no volume. So guys, this is where we're at. Guys and gals, if any of you women are watching, this is where we're at. This is what we're going to try. And I'm going to close out this video right here and regroup and see what we can come up with. And obviously, great thing for the comments section. Any of you who are a little better with load lines and things than I am, I would be flattered if you would offer up, you know, any of your thoughts on this as well. All right, guys, thanks for being with me. Thanks for watching, and more to come.